Okay, let me grab the algebra stuff real quick. All right, here we go. Which one? 40. Let's look at 40 real quick. All right, yeah, let me just start this one over because this was the hard one. If you can do this one, you're in good shape. There's lots of ways to do it. All right. Now, personally, lots of options here. But when you look at the square root of 75, I hope everybody sees 5 radical 3 now. Everybody see 5 radical 3? Mm-hmm. All right, so let's do that. Let's put that as 5 radical 3 and 12 even.
2 radical
3. Yes, but there's a 2 out in front.
Radical 3.
Wow, thank you very much. 4 radical 3. All right, so now what is 5 radical 3 minus 4 radical 3?
1 radical 3.
Radical 3. So now 3 radical 5 times radical 3, which is what? 3 radical 15. You okay with that? All right. Somebody else? Yes, good. Brian, come on.
Number 10.
All right, let's take a look at number 10. All right, very, very good problem. Somebody else? She didn't want me to go any further. Good.
Number 6.
Just double checking it.
Yeah.
About that. Remember, you can't reduce things. Good job, Hayes. What?
Can you just go over 10?
Yep, I can. All right, here we go. All right, let's take a good look at it now. All right, listen to what I'm saying now. Square root of 6 times the square root of 6 is what, Hayes?
6.
Good. That's exactly what you should say. Then there's a 3 out in front, right? So now you understand where I got the 18, right? Radical 5 times radical 6. See, because it's up there, right? Because you're multiplying radicals. Do you agree with that? You with me? And then we're done. All right. Now, be careful, please, because people think that I can eliminate or I can reduce like 6 and 30. No, I can't reduce 8 and 6. Things bound by addition and subtraction, you cannot reduce. All right, unless there's a common factor in each term. All right, Simon.
So why can't you divide 18 by 6? So I did 18 by 6, 3. And 3
Oh, yeah, I
minus
erased the 1. I erased the 1, sorry. The reason is for this reason. Please watch, look up on the board. Because when you come to take a standardized test, you're going to forget this. All right, and I learned quickly that I could figure things out because I couldn't remember all the rules. So here's what I'm telling you. If I said to you, 4 minus 3 divided by 4, is the answer negative 2? Not even close. See what I just showed you? So I can't just divide. I just can't cross things out. Does everybody agree? Does everybody see what I'm trying to show you? If you're not sure, make up a problem.
So the answer would be negative 2?
No, the answer is 1/4.
Oh, okay.
That's what I'm trying to show you. So can I reduce by 4? No. Now, why am I showing you that? Because that means you can't cross those out. Right? Now watch this. If it was 8 minus 6 over 4, I can divide everything through by 2. So it would be 4 minus 3 over 2.
So you're saying you can't completely get
No, I'm not saying that. I'm saying because I can't just cross 8 and 4 out and make it a 1 and a 2 and be done with the problem. You hear me? I have to do it to everything, all 3 terms. So these 3 terms here, and some of you may have not even understood what I said by a term. There are 3 terms. Look, 1, 2, there are 3 terms. All 3 of those terms can be divided by 2. So I can divide by 2. Not all 3 terms are divisible by 4, so I can't divide by 4. Yes?
all those terms divisible by 6?
Which one?
In the
Very good, very good, very good. Okay, so The next problem we have is people say, well, everything's divisible by 6. Is 30 divisible by 6?
No.
Yes. However, it's what? It's a radical, or it's irrational, right? You can't divide this number right here, which is a rational, by a irrational. All right? Those you don't divide. Is everybody with me? All right?
12.
All right, let's take a look at 12. Here we go. So for number 12, everybody in here should be looking at square root of 18 and not even say square root of 18 ever. You just say that's 3 radical 2. So you simplify that first. Do you hear me? Now, can I reduce the 9 and the 3 this time? Because it's bounded by what? It's bounded by multiplication and division. So you can reduce them. There's no addition and subtraction involved, so you can reduce. Boys, you with me? Michael, you with me? Connor, I know you're with me. Right? So you're writing all this stuff down because I don't think you did a bit of the homework. Help yourself out a little bit today. Now you're multiplying the top and bottom by what? Radical 2. Well, I don't remember who asked me. Is that okay? Everybody good with that? All right. What, Ryan? 20. Let's take a look at 20. Very important problem. This goes to what you were asking me, Mary Ellen. 12 divided by 4 is what? 3. Now I can divide the 20 and the 5 because they're both what? Radicals. So 20 divided by 5 is the square root of 4. What's the square root of 4? 2. That's what we're doing. 3 times 2. Come on, what is your head about to explode for? You having trouble with what? 12 divided by 4? 12 divided by 4 is what?
3.
Good. There we go. That wasn't mind-blowing. What?
I don't understand why you can divide the 12 and 4 here, but you couldn't divide the 2.
Do you see addition and subtraction? That's why. Right? Because look, and again, some of you who don't, it's not that you don't believe me, but you're not sure. Try something like this. 4 times 8 divided by 4. Can I cross out the 4s? Yeah, well, let's see. Let's say I don't know. Well, what's 4 times 8? 32. 32 divided by 4 is 8. If I take 4 and divide it by 4, I still get what? 8. So can I reduce through multiplication? Yes. Can I reduce through addition and subtraction?
No.
I'm telling you, that's how you learn. You don't remember the rules. That's perfectly fine. Just like I tried to show you how I knew x squared cubed is x to the 6th. Not because I remember the rule, but because I knew x squared cubed meant x squared times x squared times x squared, and x squared meant x times x times x. How many x's? 6. So I just discovered the rule. Right? I learned the rules. I didn't need the teacher to explain to me the rules. That's what I'd like you to try to do. Learn the rules. All right? Figure them out on your own. Right? And the next thing I keep trying to tell you guys, you will be super smart if you learn to look information up. Right? Most math problems, if I don't know how to do a math problem, I type in the exact math problem and the math problem will come up on Google. And it'll explain step by step how to solve the problem. There's this thing called Wolfram Alpha you can get and as a program, and you type in any equation, any math problem, and it'll solve it for you. All right? And it'll go detailed step by step of how they solve the problem. It's amazing. All right? So again, no excuses now. All right? No excuses. All right? Let's move. All right? So I want to talk about today radical equations. You guys got that up, right?
Mm-hmm.
Now I promise you, this is super what?
Easy.
Super easy. All right? How do I undo a radical? Yes, you multiply it by itself actually, or we square it. All right? Now, if you look on your calculator, if you look on your calculator, the functions, we're not going to use it. I would just like you to look. Functions are grouped together by inverses. All right, what do I mean by that? Well, what's the inverse of addition? What's the inverse of multiplication? What is the inverse of square root? A square. What's the inverse of a square? Square root. And what I'm trying to do is I'm trying to show you that those inverses are grouped together. Now I'm going to put this up on the board, and you don't even know what it is. Log. All right, but look on your calculator where it says log. What's the inverse of log? 10 to the x. Beautiful. That means you're listening. You could also go to what's called the natural log. All right, what's the inverse of the natural log? No? E to the x. Brilliant. Those guys who are listening. All right, now I have sin, which stands for sine. All right, the inverse is sine to the negative 1. There's a cosine, inverse cosine, tangent, inverse tangent. All right, your calculator groups functions with inverses. So if you have one and you don't know how to solve it, you can look at your calculator and it'll tell you how to solve it. All right, so the square and the square root button are together because they are inverses of each other. That means if you have a square, you use a what? Square root. If you have a square root, you use the what? Square. That's how simple this is. All right? So now, here we go. Quickly, zipping through this. Here's what I want you to write. Square here and a square there. What happens to the square and the square root? They cancel. So your grade is equal to 49.
What?
You know about that grade. Number 3, how do I do that? Square both sides. Wow, you did some arithmetic correctly today.
I didn't even hear you. Oh wait, and then you divide.
Wow. Good morning, Connor. He's on it. All right, here we go. A little bit harder now. All right, we're squaring again. All right, now, again, you're squaring them individually. So what's 2 squared? What's the square root of 2 squared? There you have it. So u equals 8. That really was not that hard. All right? Now, the only condition is now, it's like a variable. You have to isolate the radical first. Isolate the radical first. That means I have to do what? Bring the 6 over. But we don't have to put a plus 6 anymore because we're brilliant. The square root of g is what?
9.
Therefore, g is?
81.
Good job. G is
What
81.
about the 6?
I added 6 to both sides, Connor.
Oh.
Isolate the radical. You're isolating the radical. All right? So here, nothing to isolate. It's already isolated, correct?
Yeah.
So now we square both sides. 2t minus 1 equals 25. 2t equals 26. T equals 13. Go. Come on. Exactly. 26 divided by 2, 13. What? Because it's under the radical. Good question. You with me? Do you hear what I said? You isolate the radical. Anything outside the radical, you have to get rid of. All right, so on number 11, what would I do first?
X plus 4 equals 3.
Square root of x plus 4, thank you, equals 3. Squaring both sides. X plus 4 equals 9, so x is equal to 5. Good, Connor. What?
Wait, so when you square the radical, it just takes away the radical. You don't
Exactly
square
correct. They're inverses. Exactly. You hear me?
Yes.
Did you see I added 2 to both sides, right? All right, I have divided by 3.
Multiply by
So you have to multiply both sides by 3. So radical d equals 12. D equals 144. Come on.
How do you get 144 plus 12 times 12?
Yes, sir. 12 squared is 144. All right. Now, a little bit harder now. All right, a little bit harder. So please pay attention on number 15. All right, please pay attention on number 15. All right, we have to square both sides. All right, I really need your attention now. All right, so I have x squared equals x plus 2. Anybody have any issues with that so far? Now, this is called a quadratic. So you have to set it equal to 0. So to set it equal to 0, we have x squared minus x minus 2 equals 0. All right? Everybody good?
Why is it reduced?
Because I moved the x and the 2. All right? When I moved them, I changed the sign. All right, now you have to remember how to solve a quadratic. We have to factor.
X.
Yes, here we go. Watch, please. 2 sets of parentheses. All right? Now, they don't make these too hard. All right? X times x. And the factors of 2 that make 1. 2 and 1. Minus 2 and a plus 1. All right, the reason why it's a plus 1, remember, it's negative 2 plus 1 gives me the negative 1 for the middle term. And then negative 2 times positive 1 gives you that negative 2. All right, come on now, really pay attention. All right, because this is a good review of factoring now. All right, and so your solutions could be x equals 2 or x equals negative 1. All right. Now, that would be the answer for a good student. All right. The answer for a great student would be that x equals negative 1 is an extraneous solution. All right. So listen to what I'm saying now. A square root can't be negative. Everybody hear me? If I said, what's the square root of 9? You don't say negative 3. Right? The square root of 9 is what? 3. The square root of 9 is 3. Every time I ask you for a square root, the answer will be what? Positive. All right, so now listen to what I'm saying. So if x is negative 1, now I need you, some of you guys got your head down doing other things you think are important. If I put negative 1 in for x, is it possible for this square root to be negative 1?
No.
Not possible. Right? So for radicals, you always have to check. The answer can't be negative. All right? The answer can't be negative. Or I should say, the square root can't be equal to a negative. The x value can be negative. All right, that's why you have to double check and verify. All right, so let's look at number 17. What am I doing? Squaring. So 6x minus 9 equals what? X squared. Come on now. Quadratic's got to set equal to 0. So x squared equals 0. Beautiful. Okay, now you got a factor. Good job, James. Minus 3 and minus 3. So the only answer is what? X equals 3. All right, x equals 3. Yes.
So you're only doing the quadratics because it's equal to x.
X squared. There's an x squared.
So like,
when you square it, you're going to come up with a quadratic.
so like for 9, since it was equal to 5.
Yes, that's exactly correct.
Can you explain to me
like what for the equation like x squared minus 6x plus 9, like what do you use to get the x things?
We said that the x squared is broken down to x times x, right? Then I'm looking at the factors of 9 that make 6.
Oh.
Remember that? 3 times 3 is 9, 3 plus 3 is 6. Yes, good for you.
Why would it not be negative 3?
Because remember, good question. Remember, I skip a step. It's x minus 3 equals 0.
Oh. Alright.
Right? Okay, now, I'm going to be honest. 19 is a pain in the butt. All right, so everybody take a look at this. All right, you still have to square both sides. So I have x plus 5. Now remember, x minus 1 squared is x minus 1 times x minus 1. So I have to multiply that out. So it becomes, please make sure you know, x times x is what? X squared. Now we got to do the little smiley face. Negative 1x and negative 1x makes what? Negative 2x. And then negative 1 times negative 1 is positive 1. Right? So everybody okay with that? All right. Now, we have to set it equal to 0. All right, so I have to subtract x and subtract 5. Subtract x and subtract 5. So x squared minus 3x minus 4 equals 0. So everybody see that? Come on, Connor. You got to keep going. All right, now we have to factor that. Exactly, thank you. So x times x, negative 4, and a plus 1. So x equals 4, or x equals negative 1. Because you're listening, you probably know negative 1's not going to work, but we're going to double check. All right, so I go back. Now, this right here, if I plug negative 1 in for x, hope you're listening to me. If I plug negative 1 in for x, what's negative 1 and negative 1? Think for yourself. I said, what is negative 1 and negative 1? Negative 2. Can a square root be equal to negative 2? No. So this is not an answer. It's called an extraneous solution. You did all the math correct, all right, but you still came up with a false solution.
Why did you? I know you're not supposed to have like the negative. So is that like so? If there's like a negative number, you switch it to a positive.
No, I did not.
Well, then why is the 4 positive?
Drew, explain to her why the 4 is positive.
Because
No, you asked me that question earlier. That's why I called on you.
It's because it's x minus 4 equals 0, so then you have to do
Exactly.
plus 4, so then it's
We skip a step. All right,
yeah.
we skip a step. There's a step. X minus 4 equals 0. X plus 1 equals 0. Right?
Why would it be positive?
How do you solve x minus 4 equals 0?
Oh,
Right? You're adding 4 to both sides. Good on that or not? All right, come on, kiddo. All right, so number 21, what do I have to do to both sides? Nope.
you have to separate.
Separate. Exactly.
It's r minus 3. And
So
r
it would
minus
be
5
the
squared.
square root. Very good. The square root of r minus 3 equals r minus 5. Now we're going to square both sides. R minus 3 equals r squared minus 10r plus 25. Now there is a pattern to that. Let me try to teach you the pattern. Look up so I can show you the pattern of how quickly everybody should be able to square a binomial. All right, here we go. Pay attention now. R squared is the first term. The middle term is always R times -5 times 2. So what's R times -5? -5R times 2. That's a pattern. All right, I'd like for you to know that pattern. All right, -10R. And then the last number is what? Squared. So what's -5 squared? That's where you're getting that from. Okay, everybody good on that? All right, so now we have to set it equal to 0. To set it equal to 0, I need to subtract R and add 3. Subtract R, add 3. When I do that, I get R squared minus 11R plus 28 equals 0. Now someone else besides James, tell me how to factor R squared minus 11R plus 28. Go.
So you put parentheses.
Good.
It's R.
Good.
And the next one's R.
Good.
It'd be 5 times 5.
Why? Whoa, whoa, whoa! Look up.
Oh, 28.
What is that? What's it going to be then?
You can do 7 times
7 and 4. Good job, girl. 7 and 4, and they both are.
twice.
They both are.
Negative.
Yeah. You with me?
Mm-hmm.
And so now, R equals, or R equals 4. However, when we isolated, we have this. Please look and pay attention because this is where kids make mistakes. When we isolate it to what? R minus 5, correct? So does 4 work? No, because what is 4 minus 5? You see that, guys? 4 minus 5 is negative. All right? So that's why this is not an answer. All right, because look, I'm going to plug a 4 in. Look up on the board. I'm going to plug a 4 in. All right? I'm going to plug a 4 in right there for that R. What's 4 minus 5? Can a square root be negative? No. Does everybody see that now? What? Good, Connor.
How do I know when to do like R minus 5 and R minus 5?
Because you have to isolate the radical. All right? See how this plus 5 right here was with the radical? I had to move that to the other side.
Oh.
All right? Now, number 23. Square both sides. So I end up with 5n plus 4 equals. Now, look up. There's a pattern. We're squaring n plus 2. All right? So equals n squared. Now, the middle term is n times 2, which is
2n.
then times 2
Plus 4.
plus 4n. Good job. And then plus what? Plus 4. All right? Now we set it equal to 0. N squared minus n equals 0. Anybody have any complaints about that? The 4's cancel, agreed? Now we factor out an n, GCF. N times n minus 1 equals 0. So n equals 0, n equals 1. Do both of those work? Yes. Because if I plug 0 in, it's positive. If I plug 1 in, it's what? Positive. Do you understand how I factor out an n? So then you set that equal to 0. Then you set n minus 1 equal to 0.
Yeah.
Okay, so n squared minus n. If I pull out an n, there's 1 n left.
Oh, okay.
Right?
Okay, so I still don't get Okay. How'd you get the one? Because like you pull out an n, so it's just one n.
Yes.
And like minus.
Yes, you're dividing. Remember what I tried to tell you, you're always dividing. So n divided by n is 1. Or I want you to think about this real quick, Connor. Look, what's n times n?
N squared.
And what's n times 1?
1.
There you go. You see that yet?
So well, I'm just saying like there's always a 1 before the n.
Yes, that's also true.
So wouldn't it be n minus 1n?
No, because there's only a single n here. Listen to what I'm trying to tell you. There's how many n's here? 2.
Oh.
How many n's here?
1.
So
So you're saying okay, I get it.
So pull it out. Good, Connor.
What happens to the 5n plus 4?
What happens to the...
It's like not good, right?
No. What I did was I subtracted 5n and subtracted 4.
Oh.
Subtracted 5n and subtracted 4. All right. How much time do we have? Okay, so listen, I'm actually kind of happy with how some of you reacted today. And again, I would like to say 16 through 24, those require it's not that they're hard, they just require extra work. All right, so now there's a whole nother page. All right, so again, I'm not interested in going through that page. Maybe we can do that page tomorrow as well. But listen now, I'm giving you a little bit of break here. All right, and I'm trying to tell some of you guys, if you're having trouble, that's what the YouTube is for. Go back and listen. Go back and listen through it. You're trying to be great students, right? Not knowing is your fault. All right, I'm asking you, if you come in the morning and ask me questions, I don't know how to do something, I'll help you with any problem, right? But you have to do some work on your own, all right? So your job, let me make myself clear, because some of you seem to not be clear yesterday. All you have to do right now is the evens on the first page. All right, the evens on the first page. If, you want to get some extra practice in, that's the other page. All right. Again, what I will probably do is I'll probably do the second page with my other class. All right. And because I think they're not necessarily harder, but I just think, it wouldn't be a bad idea. So if you want to look at the odds on 10.4, you can. But I don't think I'm going to post the answers to the evens. All right, and then we'll work some more tomorrow on this. Tomorrow's also the Pythagorean Theorem, which is just a squared plus b squared equals c squared. I think we did that in pre-algebra, so I don't think it's anything new, so maybe we can spend a little bit of extra time on this. But again, this worksheet is super important because there's just lots of information that you're reviewing. All right, lots of information that you're reviewing. All right. Anybody have any questions? All right, do the evens, please. All right, no excuses. Do the evens, especially 2 through 14, relatively easy. All right, so you have 1, 2, 3, 4, 5 problems. It'll take you probably 2 minutes each. Get to work.